find the volume of a solid whose base is region R if all its cross sections are perpendicular to the x-axis are semicircular. Okay, so this is your region R. I'll draw the figure on this page. So your region R is this. This is the region R. All of this. And we have to take cross sections. We have to take semicircular cross sections which are perpendicular to the x-axis. So if it is going to be perpendicular to x-axis, so it will look like this.
Yes.
Now, but if you look at it in 2 dimensions, now this one will just look like a straight line, right? It will not look like a semicircle. For that, you should watch that video that I shared with you. If you will look at it from a height, that means if you look at it from 3 dimensions, then you'll understand how this is semicircular. So it will be like this. So there will be many cross sections. So like this is just one cross section. I can have another cross section. This is another one. This is another one. And all of these are semicircular.
Okay.
Okay, so they'll be like this. Okay. So if you look at them from 3rd dimension, you will see a solid forming up.
Yes, I understand that part. I just don't know how to solve.
Find the volume.
Yes.
Okay. Now let's say this is a semicircular cross section. What we will do is we will try to find out the area of this cross section. Okay. So this is a semicircle. Now we know that area of a semicircle is pi r square over 2, right?
Yes.
Because pi r square is area of circle. Okay. Now we want to find out the radius of the semicircle. So the radius of the semicircle will be from this point exactly in the middle. This will be the radius. Okay. Now, there is no way to find out this radius, but we can find out the diameter of the semicircle. So we will first find out this entire length.
Just curious, would that be the bottom function minus the top function, or the
top function minus the bottom function?
Okay.
That will be the diameter. This point, so this point minus this point will give us this entire length. So that will be the diameter. Okay, so r of x, because the radius will be the function of x. So that will be f of x minus g of x divided by 2. Okay. Now, in this question, this curve is y equal to x squared, and this curve was y is equal to cosine x. So radius will be, top function is cosine x.
Yes.
And the bottom function is x squared all over 2.
Okay.
Now to find out the volume, what we have to do is we have to take all the cross sections from this point to this point.
Okay. So you would do integral of, or from 0 to...
Yeah. 0.824.
Oh, yes. 0 to 0.24.
We add the areas of all these cross sections from 0 to 0.84. Okay, add the areas. So you know that area is pi r square over 2 dx. Okay, so pi over 2, and r of x is this. Okay. So cosine x minus x squared over 2 whole square and dx. Okay. So if you take whole square, so 2 square will become 4. 4 times 2 will become 8. So you can bring pi over 8 outside the integral.
Okay.
So pi over 8 times integral 0.80 to 0.824. And we're just left with cosine x minus x squared whole square dx.
Okay. So pi over 8, 0.824 cosine x minus x squared the whole squared dx. That's it?
Yeah.
Okay.
So, but you have to evaluate this.
Yes, yes.
Okay, it will be, I don't know, you can find out this value times pi over 8.
It would be like 0.172.
Okay,
Okay.
so this was semicircular cross sections. Then in number 12, you have to take triangular cross section, right?
Mm-hmm.
Tri Equilateral triangles, which are perpendicular to the y-axis. This time we have to take
Okay.
equilateral triangular cross section.
Mm-hmm.
Okay, so I'll get this figure. Okay, now your cross section will be perpendicular to the y-axis.
Okay.
But still, it will look like a straight line to us. In 2 dimensions, it will still look like a straight line. Okay, perpendicular to the y-axis will be, let's say, like this.
Mm-hmm.
Oh, okay. And I think in this question, you have to take, you don't have to take region R. You have to take region S, not R.
Yes. For
Okay,
9 or 12?
for 12.
Oh, for 12. Okay.
12. You have to take region S, and all cross sections perpendicular to the y-axis are equilateral
Right.
triangles. So your region S is this. Okay, so you have to draw it. Okay. Okay, so region S is the bottom one, and the cos function is coming like this. Okay, so now you have to take triangular cross section perpendicular to the y-axis. So let's say this is it. Again, it will only look like a straight line, but now you have to imagine that this is a, like, let's say you're looking from it, you're looking at it from top. So you see these triangles. Okay,
Okay. Yes.
okay. And all of these are equilateral triangles. Okay. Now, again, the process will be same. We will take all the cross sections from this point to this point now, because from 0, the bottommost point, to the topmost point.
Mm-hmm.
From 0 to the topmost point is 0.679.
Yes.
And we will take all the cross sections. So we'll just area of all the cross section we'll take. Now, area of an equilateral triangle is root 3 over 4 times s square, where s is the side of the equilateral triangle. And in equilateral triangle, all sides are congruent.
Okay.
Okay. So that s is, you can say this is s. Now, how do we find out s? The right function minus the left function.
Okay.
So, and this time we'll have to convert the functions in terms of y.
Mm-hmm.
Okay, so let's say this
So
is f of y, g of
cosine inverse of
y,
y minus root x or root y.
root y. Cosine inverse of y minus square root of y. So this is s. Now we just have to put it in the area formula. So root 3 over 4 times s square dy. This will be the volume. So root 3 over 4 cosine inverse y minus square root of y whole square dy. You can bring out root 3 over 4 outside of the integral. So you have this expression.
Mm-hmm.
So you can find out the value of this expression. So you have to imagine that, so this is the solid. Let's quickly draw the solid. Ln x is this. So this is your solid. Now you have to take a line which divides this solid into two solids with equal volumes.
Okay.
Excuse me. So it will go exactly from the middle, and it is a vertical line. So vertical line, kind of from the middle, not exactly from the middle, but kind of from the middle, but that doesn't matter. This line has the equation x is equal to k. Okay, now you have two solids,
Okay.
this and this.
Mm-hmm.
Okay, this solid is created by taking semicircular cross sections. Okay,
Yes.
both the solids are created by taking semicircular cross sections. So to find out the volume, okay, this point is 1, and this line is given as x is equal to 5. So this point will be 5. So you have to find out the volume of this solid. So let's call it volume 1 and volume 2. And you have to set these volumes equal to each other. Okay. So
Okay.
volume 1 will be 1, 1 to k. Okay.
Mm-hmm.
Pi times the radius function square divided by 2 dx is equal to, this is the volume of the first solid,
Mm-hmm.
and the second solid, volume of the second solid will be k to 5 pi rx square all over 2 dx. Ideally, we should not take rx for both the integrals. We can
Mm-hmm.
take small r, maybe you can take small r. Then all you need to do is just write the formula for r. Okay, so the radius function from 1 to k, it will be same for both the solids actually. So if you're taking a cross section within this region,
Mm-hmm.
its radius will be what? The top function minus the bottom function divided by 2, this one,
Yeah.
ln x. And this time the bottom function is just
It's
x.
just 0. Okay.
So you can just take ln x, that's the diameter, divided by 2. That's your capital Rx. Okay. And it will be same for this solid as well. Even for this, your capital Rx will be same. Okay.
Okay.
Okay. So let's put it in the integral 1 to k pi over 2 ln x over 2 whole square
Okay.
dx.
Okay.
Same thing here. Then k to 5 pi over 2 ln x over 2 whole square dx. 2 square will be 4, 4 times 2 will be 8. So you will have pi over 8, 1 to k ln x whole square dx is equal to, same thing will be here,
Got it.
2 square pi over 8 k to 5 ln x whole square dx. This will be the equation, and they have said do not solve the equation, so we can keep it here.
Okay.
Okay, so this is part B.
Mm-hmm.
Okay, let's see part C. Part C, you have to find a volume of solid with cross sections perpendicular to the y-axis if the cross sections are equilateral triangles,
Mm-hmm.
perpendicular to the y-axis.
Okay.
Okay.
So perpendicular to the y-axis.
Hmm.
Okay. So you would start with integral of. Would it be from 0 to wait,
Mhm.
the perpendicular to the y-axis means it's dx, right?
No,
Or
dy.
dy. Okay.
Hmm.
So then the limits would be from 0 to whatever the intersection is, right?
Mhm.
Okay. So y equals. Mm,
First, try to imagine a triangle,
yes.
and okay.
X equals 5. So I think the y value, we have to put the y value, no?
Yeah, so you have to take all the cross sections perpendicular to the y-axis from the top to the bottom.
Okay.
Okay, so the bottommost point is 0, and we are going all the way up to this point.
Mm-hmm.
Are you allowed to use graphic calculator here?
Yes.
So we can see on Desmos what is the
So
point of
it says 1.609.
it's the y coordinate.
Uh-huh.
Yeah, x coordinate is 5.
Yes.
1 point.
609.
Okay. Okay. So we have to integrate all these cross sections from 0 to 1.609. And area of one triangle will be root 3 over 4 times side square, this time dy. And
Do
the
we can always write the root 3 over 4 outside, right?
yes, because that's a constant, so
Yes.
it not affect the integration. So you can first, in the first step, write it inside the integral,
Okay.
because the formula of area of equilateral triangle is root 3 over 4 times side square.
Okay.
Now the side will be, so this is S, if you take one cross section. Okay, so side will be this function, this
Mm-hmm.
function minus this function. Now this is the line no, this is the line y equals, sorry, x equals 5. This is a vertical line,
Mm-hmm.
x equals 5. Okay, so, and this line, this curve is y is equal to ln x. So
Okay.
you have to convert in terms of y this time.
Oh, okay. Okay.
So this line is already fine. This is in terms of y.
So it would just be x, so 5 minus
Yes, e raised to y.
e
So if you,
raised to y. Okay.
yeah, x will be e raised to y. 5 minus e raised to y will be the side.
Mm-hmm.
So you can bring root 3 over 4 outside. So 0 to 1.609 and 5 minus e raised to y whole square dy.
Got it.